Hi, welcome everybody. It's my pleasure to welcome you to our webinar today on behalf of the Activate Learning team and our team of presenters. I would like to share with you today a number of things, but really our focus today is to share ideas in which you can use your district's American Rescue Plan funds to enhance student learning, to increase engagement of your students, and to deliver your instruction in a multiple varieties and formats. So the strategies and tools that we're going to share today can be applied in a variety of ways using digital tools or your own program-specific applications. We will highlight several, let me move my screen here, several things during our presentation today. How can you deliver remote and hybrid instruction with an interactive digital resource? How do we address learning loss by implementing OnPar, which is a formative assessment program? And then how do you support after school and summer learning programs with Engineering the Future? So within our presentation today, we're hoping that you come away with ways that you could utilize these types of tools in your instruction and utilize those American Rescue Plan funds to help you bring these to your district. And with that, I'd like to introduce our presentation team today. My name is Michelle Tyndall. I'm a former K-12 curriculum coordinator, and I'm a professional development facilitator for Activate Learning. I've had many years of experience in K-12 education, from a teacher to a department head and curriculum coordinator. And I'm happy to be here with you today. We also have Ellen Mintz. She's a former K-8 teacher and instructional coach. She is also a professional development facilitator for Activate Learning. And she'll be talking with you about OnPar this afternoon. And finally, Gary Kurtz, he's a retired high school science teacher. He is a high school curriculum specialist and a professional development facilitator for Activate Learning as well. And Gary is going to introduce our Engineering the Future program for you and talk about how that program can be used for after school and summer school opportunities. So with that, I would like to turn our focus to increasing district preparedness for using our resources to deliver instruction remotely, to deliver hybrid instruction. And this really comes from my background last year as our district entered into remote instruction in March with the influx of our COVID needs. And at that time, we had a lot of feedback from our stakeholders. As we had our closing of school and flipping to remote instruction, we heard from our teachers. Our teachers were wanting to streamline applications for teaching, streamline ways in which they would create assessments and plan presentations and plan their lessons. How would they assess students? And then how would they give feedback to students? So there were a lot of needs from our teaching staff at that point. We also heard from our students and from our parents. Again, they wanted to streamline applications. How can we minimize the number of different websites our students are visiting? And how can we more uniformly have students logging in and navigating and using these different websites for assignments and assessments and getting their remote instruction? So to address that, in my coordinator position, we switched a bunch of our resources to interactive digital editions. And one of those being the iQuest interactive digital edition that we use at our middle school level. So today I'm going to highlight for you the interactive digital edition, and I'm going to use the iQuest version of that to show you some of the things that interactive digital edition can do for you in your instruction. And in general, we're going to talk a little bit about equipping teachers to deliver that instruction remotely at any time, whether it be in a hybrid or in a face-to-face format. Also doing it in a remote format. Giving students opportunities to do investigations with at-home material packs and with the digital edition instructions. And then also opportunities to use your American Rescue Plan funds to train your teachers to use interactive digital editions or online assessment programs and to implement their instruction. So with that, I'm going to switch my presentation to our interactive digital edition. Okay, so the landing page for our interactive digital edition will look like this. And for iQuest, you'll see all the different modules that your district uses. And I'm going to go into one of our physical science modules. And from the teacher login, you'll see two different sets of resources. We have the student lessons, and then we also have the teacher tools on the right-hand side. And what's nice about this is that teachers can seamlessly look at what their students will see, and they will also be able to access their teacher resources. For on the student side, the digital edition fills a need that our students and our parents expressed early on of wanting to have everything in one place. So as you see on this left-hand side, you'll see for this module, all the different lessons that are in the module. If we were to click into a lesson, you'll see the activity that goes along with a lesson and all the instructions for the activity. If the students are doing this remotely, they might have some of these materials at home through an at-home pack or through materials that are distributed from the school that they can do some of these activities, and then they can actually put in their answers to those questions right here on the screen. In addition, you'll see the students have access to the readings. So they will have online what they would see in their print version of their module book. So everything, again, packaged all in one place for the students to access. And this teacher screen then shows you exactly what the students are seeing for their access. On the teacher side, again, there was a need for all of the tools all in one place. So taking a look at the teacher resources, you'll notice that when I clicked on the teacher tools, it opened up to the same lesson that I was looking at on the student side. So teachers can come in here and they can see the lesson preparation all in one place, the background knowledge, how do you set up the lesson, and how do you do differentiation. In addition, teachers have the lesson overview and lots of resources there with the lesson overview. Further down, you can see where this current lesson fits in with the unit, and teachers have access to the projected images, they have access to the unit overview, and then also the unit calendar. Furthermore, with the interactive digital edition, we provided remote learning resources, which are so important when you're trying to take your instruction from a face-to-face only instruction to going to remote or going to hybrid. The remote learning resources provide teachers with resources for how do you restructure your lesson plans? How do you have students doing some of these activities remotely? And then also activity videos. So if the students aren't able to do the activities in a face-to-face format, they'll have videos available for them to access so that they can see what would be going on if they were actually doing that activity. So the teacher resources are plentiful, and I'll go through some more of them shortly. But for the moment, I want to turn our attention to the student login side. So I'm going to sort of minimize my teacher side and bring forward my student side. So here I'm logged in as a student. You'll see that same landing page for the student side. So I'm going to go into the same module here. And as we look at acceptable uses for the American Rescue Plan funds, one being Title I instruction, another being literacy focus, and learning loss. So we want to make sure that we can attend to those things and make use of the funds with an IDE. And absolutely with the IDE here, we do address a number of those things. So you'll notice when we go into a lesson for the reading, as I had mentioned, your students have their print resource delivered digitally and in an interactive fashion. And in terms of literacy supports, we have many kind of baked into the interactive digital edition. So you'll notice up here where we have the little play symbol, we have an audio reading of the text. So students can have an audio version of the text as well. You'll notice that students can make the text larger, or they can make the text smaller. We also have the option for a high contrast background. Again, all of those learning supports that we may want to fit in for students that need some additional assistance with the text. In addition to those supports, we also have the opportunity for students to engage in some close reading strategies. So as we move down, you'll notice that I have some highlighted places in here. So students can go through, and as they find something that's important that they need to recall or that they might want to note, they can actually highlight that part of the text in real time in their digital edition, and they can assign a highlight to it. In addition, they can add a note. Okay, so I can say in my note for this, there we go, that this is important. And I can save that note and come back to it for future use. On this left-hand panel, you'll see that there's a notes icon. And if the student clicks on those notes, their notes for the different lessons will pop up, and it will take them to that portion of the text so that the students can see where that note was actually recorded. And so they can scroll through and they can find where that note was recorded. When they hover over it, it actually shows what that note was. If students just want to highlight, they can just highlight the portion that they want and use the highlight tools and not have to leave a note. So a number of opportunities to support our students in their literacy when we're looking at the text version. One of the other things that was important for us as we moved into closure was giving teachers and students a seamless way to assign assignments, for students to complete the assignment, and then for teachers to give feedback. So when you take a look at the activities, you'll notice that the activities and the reading give opportunities for students to make drawings of their models, to answer questions. And in this case, if we click on the draw icon here, it'll bring up the drawing palette. Students can add lines, they can add shapes, they can add text. They can even bring in pictures as well. So in this case, I'm just going to add in another quick line here, and then I'm going to show that line of sight returning back to the eye. So students can construct their models, and then they can easily submit their drawing for the teacher then to interact with on the teacher side. Taking a look over at our teacher model again, our teacher login. Okay, so we just completed part of that activity 5.2. We can come over here to our teacher tools and go to grade activity by student. So now you notice how we're able to quickly and easily take a look at what our students completed. And then once we are looking at our students, we can quickly see what's been, what activities our students have interacted with and which ones we have interacted with. So in this case, our student Abby made some additions into section 5.2. So I'm going to click into that. And then we'll load up her work. So the teachers can very quickly take a look at what the students did. And then teachers can add comments, nice job. And they can also give a score for that. So when you click on score, it's going to ask what's the possible score for this assignment. Let's say we're going to give this a score of 5. We're going to set it. And then I'm going to give Abby a 4 for this one. And then we'll be all set, and I'll save the comments. So then quickly on the student side, when Abby comes back in and she looks at her lesson 5, she'll be able to go into section 5.2 and she'll see the score. And then she'll also be able to see the teacher comments as well. So it's very seamless in its communication between students and teachers with the assessments. And then finally, with the interactive digital edition, our teachers can create assessments. They can share assessments with each other. Let me come back over here. They can grade their assessments by student. They can grade their assessments by question, and then they can also view grades. So in terms of a package for teaching and learning, very much so, this offers a lot of things that were really important for our stakeholders when we went to remote and then when we went to hybrid instruction. And with that, let me just show grades here for a second. Okay, there's our class. Come on. Oh, I don't have assessment grades. That's it. I'm looking at assessments. So in our student grades, sorry, we can view grades as well. And if I choose my class and I choose my student, you'll see that Abby has, I'm still in, there we go. There we go. And I can say for lesson 5, here are Abby's grades. And Abby's also able to check those grades as well. Okay, so let me cruise back to my presentation real quick. So with that, in terms of allowable uses of our American Rescue Plan funds, we can make use of this to increase your district preparedness to deliver instruction in any of our instructional modalities at this point. We can connect our students, and we can train our teachers using those Title II funds and implement professional learning. Okay, and then taking a look at what is also here, we have the remote learning lesson plans. We have our new teaching resources to support hybrid learning. In addition, you can make use of student kits to promote remote learning. So think of the basics of some of the equipment that would be needed for students to do activities from home. Student kits are available for you to purchase and send those home with your students. And then the other piece that's very important is that our IDE seamlessly integrates with most learning management systems, again, offering single sign-on and seamless integration with the learning systems. And with that, we're going to turn over our presentation to Ellen Mintz, and she's going to talk with you about OnPar.
Hello, everybody. Happy to be with you this afternoon, and thanks, Michelle, for really setting up a really good seamless transition. The the on-par system that I'm going to talk about is also, I think, will be hugely beneficial in terms of, let me go ahead and share my screen, addressing learning loss for students. I've been really interested in assessment for a lot of reasons, lots of which has to do with identifying whether it's the kids don't know things, students don't know things, or they just not able to communicate them. And on par is a way to really key in on what weaknesses students have and what strengths they have. It is a formative assessment program that what you see on the screen here is, I hope you see on the screen, is all of the units that are addressed by the on-par system. It can be used with any middle school program. And the one that I have open now is light, and that's the one that we're going to focus on. Each on-par unit has assessments that consists of tasks, mini tasks, and an end of unit assessment. So when you're thinking of administering them, there are unbelievable teacher supports that will help you really place students on a learning continuum. So they're not got it, don't got it kind of tasks. They really enable you to find out what learning students have, as well as strategies and ways for you to address that learning loss and move students forward. Within each task, you have sometimes mini tasks. Mini tasks were identified by the University of Wisconsin, which, by the way, is the developer of this assessment system. It's based on a lot of student data that enabled structures to be put in place to help you identify where students are. And many tasks were developed to address specific struggles that it was evident in their data that there were weaknesses. So I want to point that out to you. I just want to point out as well that there is a training video for every task. You see one paper task here. These can be done on any learning management system as well, because they're printable PDFs that can be uploaded by the student to the teacher. So if you are still engaged in remote learning, you'll be able to find evidence of student learning through that. And so there are training videos. This preview full task is just teacher slides that are the same ones that students will see. I'm not going to touch on those now because I'm going to show you that from the student side. And then I'm going to open this teacher's guide for you to see how these tasks were put together. You'll note that all of the disciplinary core ideas are called out for each task, as well as the science and engineering practices and cross-cutting concepts. This is truly a three-dimensional assessment system, and everything that you need to know about what students will be engaged in is identified for you within your teacher materials. Background goes into more detail as to what the components are that will be assessed. Now, this entire system was put together to eliminate any struggles that students who are ELL students, students who struggle with very text-dependent tests would interfere with their ability to convey their learning. So it was designed with all of that in mind. They too are able to show their knowledge so that you're not struggling with, do they not know it, or are they not communicating it? Because that's what was taken into consideration in the development of these tasks. This task information here, and I'm going to come over here and open up a student unit so that you can see them together. This is the student side. I'm logged in as a student here. I'm logged in as a teacher here. Teachers also have access to a script as to what students are seeing and how you can support them in their engagement in one of these assessments. There's multiple ways that you can administer them. They can be done together where students pause, take, answer, or respond on a certain screen, or whether or not you want to just assign it after introducing it. So I'm going to come over here to guiding questions. and show you again, these are not just, okay, let me give you this test and walk away from it. Each one begins with a set of questions that puts the context right in front of students so that they are able to recall what they've done in classrooms to address those DCIs, SEPs, and cross-cutting concepts. So, and then afterwards, once you have evaluated student responses, you are able to find ways and strategies that you can move students forward after identifying weaknesses. And we'll look at ways to identify those weaknesses when we look at the teacher reports that you'll see in a moment. So that is the guiding questions part. The interpreting scores is where you're going to find your answer key. And I have an answer key opened up for us right here. And you can see, make this a little bit smaller, that you have identified what the correct answer is, as well as connections to score reports that, again, we'll take a look at in just a few minutes. So that's in interpreting scores. This academic language and resources section are also strategies that you can use in addition to those we looked at in the guiding questions to move student learning forward. So I have this student side open just to give you an idea of what the tasks look like. And I'm going to click on resume task because this one has already been started. Shoot, I'm logged out. So when I hit on resume task, I'm going to go back a few screens to this one, which is show the path of light from the sun. I mentioned earlier that these were designed to eliminate struggles from students who struggled with text-heavy questions. You'll note that these can be read to students in English or in Spanish, and that there is underlined blue phrases or words that give hints to students so that they will be more able to respond. They do not give any clues as to the content. So students go ahead and answer their questions and then go ahead and submit their response. There's also a screen text button for students who do rely heavily on text so that they have that as a support as well. So once all the questions are answered, there is a submit button. And as soon as that button is submitted, the student report will immediately pop up. So I'm going to come back over here to my teacher side and go to my classroom. And I've been logged. So once that report comes up, this is the information that the teacher will get. So you'll note that on the screen that we looked at for passive light from the sun, this score report pops up for me. When I'm taking a look at this, I know that 2 students scored a 2. I have 3 that scored a 3, 2 and 3 here. They don't have the same score values because they are not all weighted equally. So when these are clicked on a live screen, the names of the students come up to show who scored that way. Down here, there is language that explains how students scored. And again, when I click on these, the names of the student who scored in that area will also pop up. So this is what a student screen looks like. And this is how I make my decisions. I can look at this and see, okay, I have 5 students who scored a 0 here. So in looking at my teacher materials that we saw earlier, then I'm able to say, I really need to go over the information on this particular screen. A student's report also gives information to the student immediately that resembles what we see down here. So it's all broken down, even in the science and engineering practices. As I said, it's three-dimensional. So in terms of really addressing learning loss and finding out what students don't know and how to move them forward, everything that you need to make instructional decisions that will benefit students are available to you. And using an assessment system that connects completely to what every state determines that middle school students should know. So that's a brief overview of OnPar, and there will be some slides that will be explained to you later that you can get more information. But I need to turn this over to Gary so that he'll be able to talk to you a little bit about what we can do to also address learning loss in after school programs.
Okay, thank you, Ellen. There. Okay, everybody ready? Thank you very much. And in continuing with this idea on how to implement these American Rescue Plan funds, I want to introduce you to a course called Engineering the Future. And if you look at my first slide, whoop, I went the wrong way. So there it is. Two sides of a coin, what does that even mean? And two sides of a coin, the reason I chose that is because NGSS, our Next Gen Science Standards, puts engineering tantamount with science. It's so important to be scientifically and engineeringly literate. And that's what this course is going to do. But the course, the reason I get excited about Engineering the Future is because of its flexibility. It can be, I've seen it used four ways. I've seen it used in a 40-minute class. It's been in block scheduling classes, but it's also been in summer school and in after school programs. So you can make one of these projects last 8 weeks, or you can make it last 2.5 weeks, depending on the amount of time you have. But because of that flexibility, it works so beautifully in after school and in summer school programs. So there's 4 projects, and you can see them right up there. I won't read the stuff. You guys can read that. But I'd like to do this. This is my plan, to go over just a little tidbit, a thumbnail sketch of all 4 projects, and then just a little summary at the very end, and I'll turn it back to Michelle at that point. So there's 4 projects. They're actually independent of each other, but I'm just going to say 1, 2, 3, 4 like that, but there's no particular order. The first project is called Jump into Engineering. And the main idea is that students are going to design some type of an organizer, and it depends on the creativity and the imagination of each group of students. But you could do a jewelry organizer, you could do a necktie organizer, you could do a CD organizer. It doesn't matter. That's the beauty of project-based learning also, that many kids can go different directions but still come up with the right answers. So one of the first things they do is they take and they modify or redesign some kind of an accessory for a mobile device. After that, they get into some engineering drawing. At that point, you can also use CAD, the computer assisted drawing, if you'd like to do that. But the idea is designing this organizer and actually making it come to fruition. So they also do sort of like a cost analysis of it. They do a life cycle of all the materials that they're going to use when they get started to when they're in the junk pile. What does all that go through? And look at manufacturing pretty closely. So it's and probably the biggest thing is they're introduced to the engineering design cycle, or the engineering, the whole strategy of solving a problem. And after doing this unit, every other unit will have that intact also. They look constantly at the engineering design sign, which is really a transdisciplinary idea anyway, but it's a great problem solving strategy. Next, I have some pictures of Project 1. So these are students doing that. And when I look at that, the crux of this picture to me is that you can do this project without buying very much equipment at all. It's just things that are in an office. It's scissors, it's rulers, it's glue, it's tape, it's papers, it's cardboard. It's very cheap to implement, but it's a very good start on trying to get engineering into the science programs. Project number 2 is design a green building. And this one, they're looking for some purpose for building a new building in their community or in their neighborhood, or why would we need this, or what can we do to refurbish, replenish this building right here? So when they're doing that, the first thing they do is they get to test all kinds of structural materials. They can do compression tests, they can do torsional tests, they can do different bending tests, lots of different things they get to work with in this. Then they're going to design a floor plan for their building, which again, they can use CAD if they have that. And those are actually free programs that you can get anyway. They will look at the environmental impact that their building has on the community. They'll look at all the different systems in a home, such as the electrical system, the lighting system, the HVAC system. We'll look at insulation, R values, what all that means. And then they go ahead and design and build their house after a series of tests. So I've got a picture here. I'm going to do 3 things here. The bottom left picture is a CAD drawing, the computer assisted drawing of somebody's floor plan. The top left photo is one of the buildings they're going to build, and they're going to take that and crush it to failure and find out why it failed. And the top right one's a fun one. And I didn't mention this yet, but in this project, all the groups get to design different forms of concrete. And so they use different aggregates. They use different amounts of cement, varying amounts of water. And we try and look at what can we take out of a dump that we could make concrete with, really trying to make green concrete. So they make little cylinders of this, and then the next day they're dried. Then they take them and crush them and measure the compression strength by using a first-class lever, which you see right there with a set of scales on there. So they learn an awful lot about building a house, designing a house, everything that goes into a house. And again, to reiterate one more time, it's so flexible that you can use this in summer school and after school in short durations of time, especially if you have a couple hours a day to do this work. The third big project is called Patent Your Vehicle Design. And this is, and I don't know how many of you have heard of this, a little putt-putt boat. And a putt-putt boat is a moving boat that has no moving parts, but it zooms around a bathtub, zooms around a swimming pool or a lake. And what we do is we redesign that putt-putt boat. And the way that happens is through reverse engineering. When you reverse engineer anything, you tear it apart, you analyze it, you find out how it works. And eventually we're going to try and make it a better product by understanding how it works. So they're going to learn about hydraulics and pneumatics. They'll study the auto engine. They'll study combustion engines, diesel engines. They will even have a part in there on rocket engines. And then they try and redesign that putt-putt boat and come up with a patent of their own that shows the redesign they did. It's probably the most favorite chapter or the favorite project that students do because it really engages students. Now, look down there on the left, and that's a picture of a girl cutting a pop can. That pop can, the aluminum, is how we make our boiler. The boiler's got to be airtight and sealed up, but it's easy to make with cans. On the far right, on my picture anyway, there's the hull of the boat. The hull of the boat comes from orange juice cartons, Tropicana juice, or milk cartons. So you can build this boat so cheaply, and it's so much fun. And you will look at the look on students' eyes after they build a working boat is so cool. And then we have to really study, how does that boat work? So they know Newton's laws, and we get into the gas laws. We do lots of studies of science to understand how that boat even works and the science principles behind it. The fourth and final project is called Design with Light and Sound. And this one is their study of electricity, of circuits, how to use a multimeter, a voltmeter, an ammeter in their everyday life, in their garage or in their basement, wherever this stuff is. And we make those things also. They also are going to build headphones to listen to that work, operable headphones. They're also going to do a speaker system and build an AM radio. And then the final project is to communicate with another group in your class. Now, to do all that, we use snap circuits. So snap circuits will come with us, and that's the way we can do the radio and all that. This is some examples, some pictures. The top middle one is one of the headphones that the students built. The top right one is a speaker system for an AM radio. So look what we've got. Cardboard boxes that vibrate and make longitudinal waves, cups, rubber bands, magnets, LED lights. It's not very expensive to implement this, and using the funds, the American Rescue Funds, is not expensive at all to use Engineering the Future. I didn't say this, I'm going to say it right now. This was really developed at Boston Museum of Science, and it comes from there, and is an unbelievable curricula. This, you can read this stuff on your own, but if I was to summarize this, I would say this is about STEM. It's showing that science, technology, engineering, and math are inextricably intertwined together to produce this product. It gives students a great appreciation of STEM. And to show you how old I am, when I was teaching in the 1990s, we called it SMET, S-M-E-T. And then in like 2002, 2003, they had a congressional hearing, and Dr. Romilly converted it to STEM. And that's where STEM has its genesis in 2003 at a congressional hearing. Just a note to throw in there to you guys on that. But that's what that. Second one, what is it? Well, what it is, it's, to me, again, it's a low-cost program for after-school, summer school. It has, and I've written down there, it has a very low barrier to math. But to me, the biggest thing that I get excited about is that each project provides the context for the retrieval and the application of the science and engineering principles that they're being taught and they use. It's just not memorizing something and having it in your head, but it's actually applying it. That's what these projects do. They provide that vehicle to help in the application of this stuff. I think that's a cool thing to talk about. YETF, again, you can read that stuff on there. Here's what it means. It's engineering the future for everybody. This is not for kids that think they want to be engineers. This is introducing engineering at the level for everybody. And what you've got a teacher's edition, you have a student edition, and the teacher's edition, let me back up. The TE is one of the best TEs I've ever seen, and I've taught a lot of years. It's really a good one, and especially the pacing guide in that thing. The student edition are 30 vignettes written by engineers and designers that go along with what they're reading about and what the labs are all about. And then you have a project notebook for each project that students record their answers in. So it really makes it easy. And the final thing, then I'll turn it back to Michelle, is I just wanted to show you part of an activity to give you an idea, because you hear me postulating all this stuff, but here is the real thing. So I've got some forces down there, and we're going to actually look today, and you can see tension, compression, torsional forces, and shearing forces. But here's tensile strength, and here's one of the things we're going to do. This is a piece of paper. You can get cardboard. You can get different thicknesses of paper. You can take rubber bands. You can take anything plastic, anything elastic. And the tensile forces, when you pull, and how hard does it take you to pull until you tear this, until it breaks? So here's the piece of paper we're going to do. And I take a little piece of sandpaper and cut it in half like this. So I have two pieces. Then I fold them over to provide some friction. So I'm folding this one over. Then I'm going to stick this little piece of paper and put that sandpaper around it and put a clamp on it, a cheap clamp from Lowe's. You don't have to go expensive at all. Then I'll take the other end of this and put it around my piece of paper and put the other clamp on it. And so now I've got this clamp, this piece of paper, or this piece of plastic, or whatever you want, clamp between these holes right here. Then I'm going to take this little spring scale, and I also have an electronic scale. And this is, you hook it here, and then you're going to pull on this, and someone in the group will read how much force it takes. And you use iPhones to film it in slow motion, and you pull, you pull, you pull, you pull until it snaps and breaks. Then you're going to draw this end of that and describe what happened, and you're going to be graphing the force that it takes to pull apart different materials via tensile strength. Most of the labs are like this. They're fun, they're engaging, and they're not expensive to do, but it's the perfect solution for after school or summer school programs to really sort of deepen the understanding of science and engineering. So with that, I will turn it back over to Michelle. Thank you.
Great. Thank you so much, Ellen and Gary, for talking about OnPar and for talking about engineering the future. So just to recap, you can make use of your American Rescue Plan funds to deliver remote and hybrid instruction with digital resources, digital curriculum resources. You can address the learning loss using a digital assessment program like OnPar, or you can also look at a modular program like Engineering the Future to support your after school and summer learning programs, also to address learning loss and really integrate STEM into your options for your students.